Okay, this is an example that's not from your textbook involving M&Ms. Mars Candy claims that the mean weight of an M&M is 0.8535 grams and the population standard deviation is 0.0565 grams. The production manager believes that customers are actually getting more than 0.8535 grams. If the production manager tests 40 M&Ms and obtains a sample mean weight of 0.8635 grams, can the claim from Mars Candy be refuted? Use an alpha of 1%. So we see those 6 items again that I had told you to read for. The first thing, the population mean is 0.8535. The second thing, the population standard deviation, 0.0565. The third thing, the words more than gives you an indication of the direction. 4, you need the sample size. 5, sample mean, you need the value for x bar, 0.8635. And the last thing, the size of the value for alpha. Alpha is 1% in this case. So when it comes down to our conclusion, we really want to be comparing our p-value not to 5% this time, but to 1%. Our hypotheses get started in the same way. We're going to state the population mean, and then in this problem we're dealing with the weight of M&M's candy. So the population mean weight of an M&M is 0.8535 grams. Okay, so going back to the exact words of the problem, that's exactly what the population mean was stated to be. And when we symbolize this, we write mu equal 0.8535. The alternative hypothesis comes from the counterclaim. The manager believes that customers are actually getting more than 0.8535, and so we write the population mean weight of an M&M is greater than 0.8535. It would be just as correct if you wrote more than 0.8535. So symbolically we have mu greater than 0.8535. So we have our null and alternative hypotheses. The alternative hypothesis using the symbol greater than gives us an indication of the side of the bell curve that the test is going to occur on. Because this is a greater than symbol, the test is going to occur on the right side of the bell curve. So we go on to the mean of the sampling distribution and its correct symbol. So again, like the last example, our sampling distribution is a collection of sample means. The mean of the sampling distribution with its correct symbol is mu sub x bar 0.8535. Okay, so it's the same value as the population mean, and then when we draw our picture, this is the value that goes in the center. What we're trying to show or prove in this hypothesis test is that we can come up with a sample mean that's significantly greater to the right of 0.8535, and if it's far enough to the right, then we have reason to reject this null hypothesis, 0.8535. Is the test going to be based on the normal distribution or the t-distribution, and why? We're going to base it, again, on the normal distribution for the same reason. N is greater than 30, and the population standard deviation is known. Okay, so more important than the sample size is really the population standard deviation. That's what you're going to look for when you read these problems all together. Today's lecture, of course, you'll always be provided with the population standard deviation, but when you see all these problems next to each other, the way to distinguish one problem from the other is by simply looking for that value of sigma. And if you have it, you know you're going to be using the method that we're doing right now. Okay, the decision rule. Remember, our alpha in this problem is 1%, and it's a test that's on the right-hand side because the alternative hypothesis uses the words greater than or more than. So we're going to shade the far right tail, the upper right tail, with 1% for alpha. The x bar in this problem may fall over here, which is to the left of this vertical line, or it may fall on the right side of the vertical line. If it falls on the right side of the vertical line, then its p-value will be smaller than alpha. Its p-value will be everything from x bar up to positive infinity. And if it falls on the right of the vertical line, the p-value will be smaller than alpha. If it falls on the left of the vertical line, the p-value, going up to positive infinity again, will be larger than alpha. And it won't be too far away from the center, so we say that it's not enough evidence to reject the null hypothesis. So you'll fail to reject the null hypothesis if you get if you get a p-value that's greater than alpha. But if you get a p-value that's smaller than alpha, you will reject the null hypothesis. So your decision rule will be reject HO at alpha equal 1% if the p-value of the sample statistic is less than or equal to 0.01. So even though the test is on the right, some students do make the mistake of changing the word less than to greater than here, which is incorrect, because even though the test is on the right-hand side, we still want a p-value that's small, because a p-value that's small ideally is going to fit inside 1%, and that's going to be enough evidence to reject the null hypothesis. So we want a p-value that's small, smaller than alpha. That's going to be the general rule. So once you have your decision rule, you can go ahead and look at your sample data. The sample statistic is x bar, that's the symbol, and the value for x bar is 0.8635. So that again comes from those 6 items that we read for when we are reading the text of the problem. So x bar is positioned on the right side of center. So if we look at the bell curve and we look at the position of x bar, it's on the right side because it's more than 0.8535. It's over here. When we end up calculating the p-value, it will be all of the area from x bar up to positive infinity. The p-value will be the area to the right of 0.8635. This is the probability of getting a sample value of 0.8635 or more. Okay, so to get that p-value, we are going to go to our calculator. Same location, z-test, stat test, z-test. And in z-test, you want to make sure stats is highlighted, not data. Stats when you don't have the raw data. Mu sub 0 is 0.8535. Sigma is 0.0565. That comes right from the problem. X bar 0.8635. N is 40. And the direction of the test, either on the right side or the left side, we're going to pick on the right side, so it's greater than mu sub 0. And then go down to calculate. And the values that you get a z-score that's positive, which indicates that the sample statistic is on the right side of center. You get a p-value when rounded to 4 places is 0.1315. And then it's a repeat of what x bar and n are. P 0.1315. So rounded to 4 places, 0.1315. This is the area to the right of the test statistic, 0.8535. Oh, I'm sorry. The sample statistic is 0.8635. So 0.1315 is the area to the right of 0.8635. So we look at a picture. Alpha is 1%. It's a small piece of area in the right tail. Our p-value, 0.1315%, which is 13.15%, is the area that starts at 0.8635 and goes up to positive infinity. And if we look at the comparison of numbers, the area for the p-value is much bigger than the area for alpha. Okay, in which case x bar is not far enough away from center for us to say that the null hypothesis is wrong. It's not necessarily wrong. So, the p-value in orange is larger than alpha in blue. Alpha can fit inside the p-value, and so we say that our sample statistic 0.8635 is not significant in this case. Okay, p-value that comes out greater than alpha is not going to be significant. If we take a look at its position, it's not far enough away from center. And if it's not far away enough from center, then it's not enough evidence to reject the null hypothesis. Not enough evidence to state that 0.8535 is incorrect. So now we go to our conclusion. Remember that we're going to come to our conclusion by looking at p-value and alpha. If the p-value is greater than alpha, you're going to fail to reject the null hypothesis. So that's what you're doing in this particular case. Conclusion is, we fail to reject HO at alpha equal 1%. You're never going to state that you accept HO. The two conclusions that you can come to in a hypothesis test are either going to be reject HO and accept HA, or fail to reject HO. You're never going to accept HO for the same reason that we don't state a person is innocent when the trial has completed. We always state that the person is not guilty. And for that reason, we're going to never state that we're accepting the null hypothesis. We're always going to say that we fail to reject it. Okay, so the last part is to look at the question that was stated in the original problem. Does the sample mean weight of 0.8635 allow the claim from Mars Candy to be refuted? Okay, so the claim from Mars Candy was that the population mean was 0.8635. After our hypothesis test, can we refute that claim? And the answer is no. The sample mean of 0.8635, I'm sorry, I stated that incorrectly. Originally, let's go back a second. Okay, 8535. Okay, in our null hypothesis, we stated that the population mean was 0.8535. Our sample mean, 0.8635, is larger than the population mean, but is it large enough for us to refute the population mean, 0.8535? And it's not. The sample mean, 0.8635, does not allow the claim from Mars Candy to be refuted. And the reason is, when you fail to reject the null hypothesis, you cannot refute the population parameter 0.8535. Okay, this number is what our population mean was stated to be in our null hypothesis. We failed to reject the null hypothesis, and so we cannot reject 0.8535. Our hypothesis test has not shown that Mars Candy's claim is incorrect. So this is the problem that students often have in hypothesis testing, coming up with that last question and how to interpret the conclusion to answer the question. We have one more test of this type in this lecture.